Logistics is the management of the flow of goods between the point of origin and the point of consumption in order to meet some requirements of customers or corporations. The resources managed in logistics can include physical items, such as food, materials, animals, equipment and liquids, as well as abstract items, such as time, information, particles, and energy. The logistics of physical items usually involves the integration of information flow, material handling, production, packaging, inventory, transportation, warehousing, and often security. The complexity of logistics can be modeled, analyzed, visualized, and optimized by dedicated simulation software. The minimization of the use of resources is a common motivation in logistics for import and export. Origins and definition. The prevalent view is that, meaning reason or speech. I cubed I to the first I florin I to the first IOI, meaning accountant or responsible for counting. The Oxford English Dictionary defines logistics as the branch of military science relating to procuring, maintaining and transporting material, personnel and facilities. However, the New Oxford American Dictionary defines logistics as the detailed coordination of a complex operation involving many people, facilities, or supplies, and the Oxford Dictionary Online defines it as the detailed organization and implementation of a complex operation. As such, logistics is commonly seen as a branch of engineering that creates people systems rather than machine systems. According to the Council of Logistics Management, logistics includes the integrated planning, control, realization, and monitoring of all internal and network-wide material, part, and product flow, including the necessary information flow, industrial and trading companies along the complete value-added chain for the purpose of conforming to customer requirements. Logistics is the process of planning, implementing, and controlling the effective and efficient flow of goods and services from the point of origin to the point of consumption. Academics and practitioners traditionally refer to the terms operations or production management when referring to physical transformations taking place in a single business location and reserve the term logistics for activities related to distribution, that is, moving products on the territory. Managing a distribution center is seen, therefore, as pertaining to the realm of logistics since, while in theory the products made by a factory are ready for consumption, they still need to be moved along the distribution network according to some logic, and the distribution center aggregates and processes orders coming from different areas of the territory. That being said, from a modeling perspective, there are similarities between operations management and logistics, and companies sometimes use hybrid professionals, with for X. Director of Operations, or logistics officer working on similar problems. Furthermore, the term supply chain management originally refers to, among other issues, having a global vision and of both production and logistics from point of origin to point of production. All these terms may suffer from semantic change as a side effect of advertising. Logistics viewpoints. Inbound logistics is one of the primary processes of logistics, concentrating on purchasing and arranging the inbound movement of materials, parts, and/or finished inventory from suppliers to manufacturing or assembly plants, warehouses, or retail stores. Outbound logistics is the process related to the storage and movement of the final product, and the related information flows from the end of the production line to the end user. Logistics fields. Given the services performed by logisticians, the main fields of logistics can be broken down as follows. Procurement logistics consists of activities such as market research, requirements planning, make-or-buy decisions, supplier management, ordering, and order controlling. The targets in procurement logistics might be contradictory, maximizing efficiency by concentrating on core competencies, outsourcing while maintaining the autonomy of the company, or minimizing procurement costs while maximizing security within the supply process. Production logistics connects procurement to distribution logistics. Its main function is to use available production capacities to produce the products needed in distribution logistics. Production logistics activities are related to organizational concepts, layout planning, production planning, and control. Distribution logistics has, as main tasks, the delivery of the finished products to the customer. It consists of order processing, warehousing, and transportation. Distribution logistics is necessary because the time, place, and quantity of production differs with the time, place, and quantity of consumption. Disposal logistics has as its main function to reduce logistics cost, S, and enhance service, S, related to the disposal of waste produced during the operation of a business. Reverse logistics denotes all those operations related to the reuse of products and materials. The reverse logistics process includes the management and the sale of surpluses, as well as products being returned to vendors from buyers. Reverse logistics stands for all operations related to the reuse of products and materials. It is the process of planning, implementing, and controlling the efficient, cost-effective flow of raw materials, in-process inventory, finished goods and related information from the point of consumption to the point of origin for the purpose of recapturing value or proper disposal. More precisely, reverse logistics is the process of moving goods from their typical final destination for the purpose of capturing value, or proper disposal. The opposite of reverse logistics is forward logistics. Green logistics describes all attempts to measure and minimize the ecological impact of logistics activities. This includes all activities of the forward and reverse flows. This can be achieved through intermodal freight transport, path optimization, vehicle saturation and city logistics. RAM logistics combines both business logistics and military logistics since it is concerned with highly complicated technological systems for which reliability, availability and maintainability are essential, telecommunication systems and military supercomputers. Emergency logistics. Emergency logistics is a term used by the logistics, supply chain, and manufacturing industries to denote specific time-critical modes of transport used to move goods or objects rapidly in the event of an emergency. The reason for enlisting emergency logistics services could be a production delay or anticipated production delay, or an urgent need for specialized equipment to prevent events such as aircraft being grounded, ships being delayed, or telecommunications failure. Emergency logistics services are typically sourced from a specialist provider. Military logistics. In military science, maintaining one's supply lines while disrupting those of the enemy is a crucial some would say the most crucial element of military strategy, since an armed force without resources and transportation is defenseless. The defeat of the British in the American War of Independence and the defeat of the Axis in the African theater of World War II are attributed by some scholars to logistical failures. The historical leaders Hannibal Barca, Alexander the Great, and the Duke of Wellington are considered to have been logistical geniuses. Military have a significant need for logistics solutions and so have developed advanced implementations. Integrated logistics support is a discipline used in military industries to ensure an easily supportable system with a robust customer service concept at the lowest cost and in line with reliability, availability, maintainability, and other requirements, as defined for the project. In military logistics, logistics officers manage how and when to move resources to the places they are needed. Supply chain management in military logistics often deals with a number of variables in predicting cost, deterioration, consumption, and future demand. The United States Armed Forces categorical supply classification was developed in such a way that categories of supply with similar consumption variables are grouped together for planning purposes. For instance, peacetime consumption of ammunition and fuel will be considerably lower than wartime consumption of these items, whereas other classes of supply such as subsistence and clothing have a relatively consistent consumption rate regardless of war or peace. Some classes of supply have a linear demand relationship, as more troops are added, more supply items are needed. Or as more equipment is used, more fuel and ammunition are consumed. Other classes of supply must consider a third variable besides usage and quantity, time. As equipment ages, more and more repair parts are needed over time, even when usage and quantity stays consistent. By recording and analyzing these trends over time and applying them to future scenarios, the U.S. Armed Forces can accurately supply troops with the items necessary at the precise moment they are needed. History has shown that good logistical planning creates a lean and efficient fighting force. The lack thereof can lead to a clunky, slow, and ill-equipped force with too much or too little supply. Business logistics. One definition of business logistics speaks of having the right item in the right quantity at the right time at the right place for the right price in the right condition to the right customer. Business logistics incorporates all industry sectors and aims to manage the fruition of project life cycles, supply chains, and resultant efficiencies. The term business logistics has evolved since the 1960s due to the increasing complexity of supplying businesses with materials and shipping out products in an increasingly globalized supply chain, leading to a call for professionals called supply chain logisticians. In business, logistics may have either an internal focus or an external focus, covering the flow and storage of materials from point of origin to point of consumption. The main functions of a qualified logistician include inventory management, purchasing, transportation, warehousing, consultation, and the organizing and planning of these activities. Logisticians combine a professional knowledge of each of these functions to coordinate resources in an organization. There are two fundamentally different forms of logistics. One optimizes a steady flow of material through a network of transport links and storage nodes, while the other coordinates a sequence of resources to carry out some project. Nodes of a distribution network. The nodes of a distribution network include factories where products are manufactured or assembled. A depot or deposit is a standard type of warehouse thought for storing merchandise. Distribution centers are thought for order processing and order fulfillment and also for receiving and returning items from clients. Transit points are built for cross-docking activities, which consist in reassembling cargo units based on deliveries scheduled. Traditional retail stores of the mom-and-pop variety, modern supermarkets, hypermarkets, discount stores or also voluntary chains, consumer cooperative, groups of consumer with collective buying power. Note that subsidiaries will be mostly owned by another company and franchisers, although using other company brands, actually own the point of sale. There may be some intermediaries operating for representative matters between nodes such as sales agents or brokers. Logistic families and metrics. A logistic family is a set of products which share a common characteristic, weight and volumetric characteristics, physical storing needs, handling needs, order frequency, package size, etc. The following metrics may be used by the company to organize its products in different families. Physical metrics used to evaluate inventory systems include stocking capacity, selectivity, superficial utilization, volumetric utilization, transport capacity utilization. Monetary metrics used include space holding costs and handling costs. Other metrics may present themselves in both physical or monetary form, such as the standard inventory turnover. Handling and order processing. Unit loads are combinations of individual items which are moved by handling systems, usually employing a pallet of normed dimensions. Handling systems include trans-pallet handlers, counterweight handler, retractable mast handler, bilateral handlers, trilateral handlers, AGV and stacker handlers. Storage systems include pile stocking, cell racks, cantilever racks and gravity racks. Order processing is a sequential process involving processing withdrawal list, picking, sorting, package formation, order consolidation. Picking can be both manual or automated. Manual picking can be both man-to-goods, that is operator using a cart or conveyor belt, or goods-to-man, that is the operator benefiting from the presence of a mini-load ASRS, vertical or horizontal carousel or from an automatic vertical storage system. Automatic picking is done either with dispensers or depalleting robots. Sorting can be done manually through carts or conveyor belts, or automatically through sorters. Transportation. Cargo, that is merchandise being transported, can be moved through a variety of transportation means and is organized in different shipment categories. Unit loads are usually assembled into higher standardized units such as ISO containers, swap bodies or semi-trailers. Especially for very long distances, product transportation will likely benefit from using different transportation means, multimodal transport, intermodal transport and combined transport. Operators involved in transportation include all train, road vehicles, boats, airplanes companies, couriers, freight forwarders and multimodal transport operators. Merchandise being transported internationally is usually subject to the Incoterms standards issued by the International Chamber of Commerce. Configuration and management. Similarly to production systems, logistics systems need to be properly configured and managed. Actually, a number of methodologies have been directly borrowed from operations management, such as using economic order quantity models for managing inventory in the nodes of the network. Distribution resource planning is similar to MRP, except that it doesn't concern activities inside the nodes of the network but planning distribution when moving goods through the links of the network. Traditionally in logistics, configuration may be at the level of the warehouse or at level of the distribution system. Regarding a single warehouse, besides the issue of designing and building the warehouse, configuration means solving a number of interrelated technical economic problems: dimensioning rack cells, choosing a palletizing method, rack dimensioning and design, number of racks, number and typology of retrieval systems. Some important constraints have to be satisfied: fork and load beams, resistance to bending and proper placement of sprinklers. Although picking is more of a tactical planning decision than a configuration problem, it is important to take it into account when deciding the rack's layout inside the warehouse and buying tools such as handlers and motorized carts, since once those decisions are taken they will work as constraints when managing the warehouse. Same reasoning for sorting when designing the conveyor system and/or installing automatic dispensers. Configuration at the level of the distribution system concerns primarily the problem of location of the nodes in a geographic space and distribution of capacity among the nodes. The first may be referred to as facility location while the latter to as capacity allocation. The problem of outsourcing typically arises at this level. The nodes of a supply chain are very rarely owned by a single enterprise. Distribution networks can be characterized by numbers of levels, namely the number of intermediary nodes between supplier and consumer, direct store delivery, that is 0 levels, 1-level network, central warehouse, 2-level network, central and peripheral warehouses. This distinction is more useful for modeling purposes, but it relates also to a tactical decision regarding safety stocks. Considering a 2-level network, if safety inventory is kept only in peripheral warehouses then it is called a dependent system. If safety inventory is distributed among central and peripheral warehouses it is called an independent system. Transportation from producer to the second level is called primary transportation, from the second level to consumer is called secondary transportation. Although configuring a distribution network from zero is possible, logisticians usually have to deal with restructuring existing networks due to presence of an array of factors: changing demand, product or process innovation, opportunities for outsourcing, change of government policy toward trade barriers. Innovation in transportation means introduction of regulations and availability of ICT supporting systems. Once a logistics system is configured, management, meaning tactical decisions, takes place, once again, at the level of the warehouse and of the distribution network. Decisions have to be made under a set of constraints: internal, such as using the available infrastructure, or external, such as complying with given product shelf lives and expiration dates. At the warehouse level, the logistician must decide how to distribute merchandise over the racks. 3 basic situations are traditionally considered: shared storage, dedicated storage and class-based storage. Picking efficiency varies greatly depending on the situation. For man-to-goods situation, a distinction is carried out between high-level picking and low-level picking. A number of tactical decisions regarding picking must be made. Routing path. Standard alternatives include transversal routing, return routing, midpoint routing and largest gap return routing. Replenishment method. Standard alternatives include equal space supply for each product class and equal time supply for each product class. Picking logic. Order picking versus batch picking. At the level of the distribution network, tactical decisions involve mainly inventory control and delivery path optimization. Note that the logistician may be required to manage the reverse flow along with the forward flow. warehouse management systems and warehouse control systems. Although there is some overlap in functionality, warehouse management systems can differ significantly from warehouse control systems. Simply put, a WMS plans a weekly activity forecast based on such factors as statistics and trends, whereas a WCS acts like a floor supervisor, working in real time to get the job done by the most effective means. For instance, a WMS can tell the system that it is going to need 5 of stock keeping unit A and 5 of SKUB hours in advance, but by the time it acts, other considerations may have come into play or there could be a logjam on a conveyor. A WCS can prevent that problem by working in real time and adapting to the situation by making a last-minute decision based on current activity and operational status. Working synergistically, WMS and WCS can resolve these issues and maximize efficiency for companies that rely on the effective operation of their warehouse or distribution center. Logistics outsourcing. Logistics outsourcing involves a relationship between a company and an LSP, which, compared with basic logistics services, has more customized offerings, encompasses a broad number of service activities, is characterized by a long-term orientation, and thus has a strategic nature. Outsourcing does not have to be complete externalization to a LSP, but can also be partial, a single contract for supplying a specific service on occasion, creation of a spin-off, creation of a joint venture. Third-party logistics involves using external organizations to execute logistics activities that have traditionally been performed within an organization itself. According to this definition, third-party logistics includes any form of outsourcing of logistics activities previously performed in-house. For example, if a company with its own warehousing facilities decides to employ external transportation, this would be an example of third-party logistics. Logistics is an emerging business area in many countries. The concept of a fourth-party logistics provider was first defined by Andersen Consulting as an integrator that assembles the resources, planning capabilities, and technology of its own organization and other organizations to design, build, and run comprehensive supply chain solutions. Whereas a third-party logistics service provider targets a single function, a 4PL targets management of the entire process. Some have described a 4PL as a general contractor that manages other 3PLs, truckers, forwarders, custom house agents, and others, essentially taking responsibility of a complete process for the customer. Production logistics. The term production logistics describes logistic processes within a value-adding system. Production logistics aims to ensure that each machine and workstation receives the right product in the right quantity and quality at the right time. The concern is not the transportation itself, but to streamline and control the flow through value-adding processes and to eliminate non-euro value-adding processes. Production logistics can operate in existing as well as new plants. Manufacturing in an existing plant is a constantly changing process. Machines are exchanged and new ones added, which gives the opportunity to improve the production logistics system accordingly. Production logistics provides the means to achieve customer response and capital efficiency. Production logistics becomes more important with decreasing batch sizes. In many industries, the short-term goal is a batch size of 1, allowing even a single customer's demand to be fulfilled efficiently. Track and tracing, which is an essential part of production logistics due to product safety and reliability issues, is also gaining importance, especially in the automotive and medical industries. Logistics management. Logistics management is that part of the supply chain that plans, implements, and controls the efficient, effective forward and reverse flow and storage of goods, services, and related information between the point of origin and the point of consumption in order to meet customer requirements. A professional working in the field of logistics management is called a logistician. Logistics automation. Logistics automation is the application of computer software and/or automated machinery to improve the efficiency of logistics operations. Typically this refers to operations within a warehouse or distribution center, with broader tasks undertaken by supply chain management systems and enterprise resource planning systems. Industrial machinery can typically identify products through either barcode or RFID technologies. Information in traditional barcodes is stored as a sequence of black and white bars varying in width, which when read by laser is translated in a binary sequence, which according to fixed rules can be converted in a decimal number. Sometimes information in a barcode can be transmitted through radio frequency, more typically radio transmission is used in RFID tags. An RFID tag is a card containing a memory chip and an antenna which transmits signals to a reader. RFID may be found on merchandise, animals, vehicles and people as well. Logistics, profession and organizations. A logistician is a professional logistics practitioner. Professional logisticians are often certified by professional associations. One can either work in a pure logistics company, such as a shipping line, airport, or freight forwarder, or within the logistics department of a company. However, as mentioned above, logistics is a broad field, encompassing procurement, production, distribution, and disposal activities. Hence, career perspectives are broad as well. A new trend in the industry are the 4PL, or fourth-party logistics, firms, consulting companies offering logistics services. Some universities and academic institutions train students as logisticians, offering undergraduate and postgraduate programs. A university with a primary focus on logistics is K1/4 Logistics University in Hamburg, Germany. It is non-profit and supported by K1/4 Foundation of the logistics entrepreneur Klaus Michael K1/4. The Chartered Institute of Logistics and Transport, established in the United Kingdom in 1919, received a royal charter in 1926. The Chartered Institute is one of the professional bodies or institutions for the logistics and transport sectors that offers professional qualifications or degrees in logistics management. CILT programs can be studied at centres around UK, some of which also offer distance learning options. The institute also have overseas branches, namely the Chartered Institute of Logistics and Transport Australia in Australia and Chartered Institute of Logistics and Transport in Hong Kong in Hong Kong. The International Association of Public Health Logisticians is a professional network that promotes the professional development of supply chain managers and others working in the field of public health logistics and commodity security, with particular focus on developing countries. The association supports logisticians worldwide by providing a community of practice, where members can network, exchange ideas, and improve their professional skills. Logistics museums. There are many museums in the world which cover various aspects of practical logistics. These include museums of transportation, customs, packing, and industry-based logistics. However, only the following museums are fully dedicated to logistics: General Logistics, Museum of Logistics, Logistics Museum, Military Logistics, Royal Logistic Corps Museum, the Canadian Forces Logistics Museum. See also. References. Further reading: Houston, James A. The Sinews of War, Army Logistics, 1775–1953. United States Army 755 pages. Online. Ronald H. Baller, Business Logistics, Supply Chain Management, Prentice Hall 2003, Donald Bower Sox, David Kloss, M. Bixby Cooper, Supply Chain Logistics Management, McGraw-Hill 2012, M. Christopher, Logistics and Supply Chain Management, Creating Value-Adding Networks, Prentice Hall 2010, V. Jones, Integrated Logistics Support Handbook, McGraw-Hill Logistics Series 2006, B. S. Blanchard, Logistics Engineering and Management, Pearson Prentice Hall 2004.